Welcome students, welcome to this session. This session we are going to see about heat exchangers in heat transfer and thermal engineering subject. In this heat exchangers topic, we are going to see about shell and tube heat exchangers, plate type heat exchangers, multi-phase heat exchangers. Heat exchanger. A heat exchanger is a piece of equipment built for efficient heat transfer from one medium to another. Okay, so it is a piece of equipment built for efficient heat transfer from one medium to another. The media may be separated by a solid wall to prevent mixing, or they may be in direct contact. Okay, they are widely used in space heating, refrigeration, air conditioning, power plants, chemical plants, petrochemical plants, petroleum refineries, natural gas processing, and sewage. The classic example of a heat exchanger is found in an internal combustion engine, in which a circulating fluid known as engine coolant flows through radiator coils and air flows past the coils, which cools the coolant and heats the incoming air. Okay, the best example is the internal combustion. So now see about the classification of heat exchangers. So classification of heat exchangers by flow configuration. There are There are four basic flow configurations. One is counter flow, concurrent or parallel flow, cross flow, hybrids such as cross flow, cross counter flow, and multiplast. Counter flow heat exchangers. The following figures illustrates an idealized counter flow exchanger in which the two fluids flow parallel to each other but in opposite directions. So this type of flow arrangements allows the largest change in temperature of both fluids and is therefore most efficient, where efficiency is the amount of actual heat transfer compared with the theoretical maximum amount of heat that can be transferred. So this is the layout of a small illustration layout of the counter flow heat exchanger. The hot flow flows in one direction and the cold flow flows in the opposite direction, but both are in the parallel to each other, but the opposite in direction. Now let's see. Hot flow flows in this direction and the cold fluid flows in opposite direction. Now let's see the concurrent or parallel flow. So in concurrent or parallel flow heat exchangers, the stream flow parallel to each other and in the same direction as shown in figure. This is less efficient than counter current flow, but does provide more uniform wall temperature. Okay, so this is the illustration diagram for the parallel flow. It means hot flow is flowing in direction and the cold flow it also flows in the same direction parallel to each other. Let's see, hot flow is flows in the direction. At the same time, cold flow also flows in parallel to and in the same direction. Let's see this one small animation of the concurrent or parallel flow. See, the hot fluids enter the tubes and same time cold liquid flow is also same parallel to parallel and in the same direction. Now see the cross flow heat exchangers. Cross flow heat exchangers are intermediate in efficiency between counter current flow and parallel flow heat exchangers. In these units, the stream flow at right angles to each other as shown in the figure. So here this flows, both the flows at right angle to each other. Here is the hot fluid entry and hot fluid exit, cold fluid entry, cold fluid exit. These two fluids are in these two streams flow at. This is one best example, one illustration diagram shows the cross flow heat exchanger, how it happens. Next, combined cross flow or counter flow. In industrial heat exchangers, Hybrids of the above flow types are often found. Examples of these are combined cross flow or counter flow heat exchangers and multi-pass multi-pass flow heat exchangers. So this is the illustration diagram for the combined cross flow or counter flow. It means opposite in direction. Okay, the flow is opposite in direction with each other. Hot flow is in one direction and cold flow is in another direction. Now let's see the classification of heat exchangers. Classification of heat exchangers. Heat exchangers may be classified into four types according to their applications. First thing, transfer process according to the construction type, according to the flow arrangement, according to the heat transfer mechanism. First, first type, according to the transfer process, it may be considered as a direct contact and indirect contact. According to the construction type, it may be classified as tubular, plate, plate fin, tube fin. According to the flow arrangement, parallel flow, counter flow, and flow. According to the heat transfer mechanism, single phase, free or forced convection, boiling or condensation, then radiation or combined convection radiation. Then two types of heat exchangers are there: recuperative heat exchangers and regenerative heat exchangers. A recuperative heat exchanger has separate flow paths for each fluid and fluids flow simultaneously through the exchanger, exchanging heat across the wall, separating the flow paths. And regenerative heat exchangers. It is a heat exchanger has a single flow path which the hot and cold fluids alternatively pass through. In a regenerative heat exchanger, the flow path normally consists of a matrix which is heated when hot fluid passes through it. This is known as the hot blow. This heat is then released to the cold fluid when this flows through the matrix, and this is called the cold blow. Now let's see the shell and tube heat exchanger. Shell and tube heat exchangers consists of a series of tubes. One set of these tubes contains the fluid that must be either heated or cooled. The second fluid runs over the tubes that are being heated or cooled so that it can either provide the heat or absorb the heat required. A set of tubes is called the tube bundle and can be made up of several types of tubes: plain, longitudinally, finned, etc. Shell and tube heat exchangers are typically used for high pressure applications with pressure greater than 30 bar and temperatures greater than 260 degrees Celsius. This is because the shell and tube heat exchangers are robust due to the due to so this is a diagram, illustrating diagram of the shell and tube heat exchangers. Okay, it's a collection of tubes. Okay, this is fully set up is called the shell, and inside the shell it's a collection of tubes. Okay, inside the tubes one fluid is flows, and in between the tubes the other fluid flows inside. Okay, so inside the tubes one one fluid is flows, and in between the tubes, in between the two tubes or in the outer surface of the tubes, the other fluid flows so that the heat may be transferred. And this is the tube side inlet and the tube side outlet. This is the inlet for the tubes, inlet fluid which goes into the tubes, inside the tubes. This is for that. The full fluid, it goes, the small gap is there, it will flow into the tubes and it comes out of the tubes and it will be collected collectively it will be collected and goes out. And this entry is for shell side fluid in. This this fluid enters into the shell side, so that this fluid goes outside the outside outer surface of the tubes. Once it goes into that and comes out, in this way. In between that, they are providing some baffles so that the transfer more transfer may occur, so that the fluid may settle for a short time, so that more transfer will happen. Okay, let's see this example. This is cold fluid entry. This is enter into the tube, and this red arrow denotes fluids from the fluids flows over the outer surface. This is a one industrial shell and tube heat exchanger diagram and its applications and use. The simple design of a shell and tube heat exchanger makes it an ideal cooling solution for a wide variety of applications. One of the most common applications is the cooling of hydraulic fluid and oil in engines, transmissions, and hydraulic power packs. With the right choice of materials, they can also be used to cool or heat other mediums such as swimming pool, swimming pool water, or charge air. One of the big advantages of using a shell and tube heat exchanger is that they are often easy to service, particularly with models where a floating tube bundle, where the tube plates are not welded to the outer shell, is available. Next comes to the pipe and pipe heat exchanger. Pipe in pipe heat exchanger is there is already a pipe way. This let's see carefully. It is a one outer pipe shell, and inside that one more pipe is flows inside that. So this is called the pipe in pipe heat exchanger or double pipe heat exchanger. We call it as the outer pipe is called the shell side and inner pipe is called the tube side. Out in shell side, one fluid is going in, and in the tube side, the another fluid will goes in. Either it may be hot or cold. Okay, this is in cell side fluid in, and this is cell side fluid out, and this is tube side fluid in. It goes through this, and it comes out tube side fluid out. This is one illustration of the pipe and pipe heat exchanger. This is the shell side, and this is the tube side. This tube is inside this shell, and this shell is also interconnected. Pipe and pipe heat exchanger. A double pipe heat exchanger is one of the simplest forms of shell and tubular heat exchanger. Here, just one pipe inside another large pipe. To make a unit very compact, the arrangement is made multiple times and continuous serial and parallel flow. One fluid flows through the surrounded by pipe, and the other flows through the annulus between the tube pipes. The wall of the inner pipe is the heat transfer surface. This is also called as an hairpin heat exchanger. These are might have only one inside pipe, or it may have multiple inside tubes, but it will forever have the doubling back feature shown. In some of the special cases, the fins are also used in tube side. So this is the industrial illustration of the pipe and pipe heat exchanger. Advantages of pipe and pipe heat exchanger. A primary advantages of a hairpin or double pipe heat exchanger is to facilitate. It can be operated in a true counter flow pattern, which is the larger amount efficient flow pattern. That is, it will give the highest overall heat transfer coefficient for the double pipe heat exchanger design. The primary advantage of a concentric configuration as opposed to a plate or shell and plate or shell and tube heat exchanger is the simplicity of the design. Also, hairpin and double pipe heat exchangers can handle high pressures and temperatures well. When they are operating in true counterflow, they can operate among a temperature cross, that is where the cold side outlet temperature is higher than the hot side outlet temperature. As such, the insides of both surfaces are easy to clean and maintain, making it ideal for fluids that cause fouling. So it is easy to clean the inside surface, inner surface and outer surface, so that we can make it free from the fluids that cause fouling. Fouling means salt, air formation. Disadvantages of pipe in pipe heat exchanger. There are significant disadvantages. However, the two most noticeable being their high cost in proportion to heat transfer area and the impractical lengths required for high heat duties. They also suffer from comparatively high heat losses via their large outer shells. Through the large outer shells, high heat losses. So next type is the plate type heat exchangers. Okay. A plate type heat exchangers consists of a series of thin corrugated metal plates between which a number of channels are formed with the primary and secondary fluids flowing through alternative channels. So there are a number of plates, thin plates arranged parallelly, and there are channels provided in this plate through that hot and cold fluid, that is the primary and secondary fluids flowing through this alternative channels. Heat transfer takes place from the primary fluid steam to the secondary process fluid in adjacent channels across the plate. The figure shows a schematic representation of the plate heat exchanger. So when the product cold fluid goes inside and the steam goes in this direction, so that heat may get transferred from the inside these two plates. So let's see the illustration of a plate type heat exchanger. The cold fluid enter inside and the hot fluid is in the another channel, and these two enter this side, so that from this hot fluid the heat is transferred to the cold fluid. Plate type heat exchanger. The plate type heat exchanger consists of a specific number of plates arranged between the pressure and the fixed frame. The plates are having corrugations with different designs, which increase the total surface area for the heat exchange. The plates are movable within the frame and rest on the carrying bar on the top and the bottom of the frame. The plates are arranged in pairs which are opposite of each other, forming a honeycomb pattern when viewed side. The plate corrugations promote fluid turbulence and increase the heat transfer. The fixed and the pressure plate are supported by the supporting column. The plates are fitted with each other with gaskets which seal the material from coming out sideways as well as through the holes on the plate. The alternative arrangement of the gaskets prevents the mixing of the fluids within the channel. The steam heat exchanger market was dominated in the past by the shell and tube heat exchanger, whilst plate heat exchangers have often been favored in the food processing industry and used water heating. However, recent design mean advances mean that plate heat exchangers are now equally suited to steam heating applications. So, advantages of plate type heat exchangers: low cost of operation, low cost of maintenance, easy to clean, highly efficient heat transfer. Future changes are possible by fitting extra heat transfer plates, less floor spacing required. Power generation applications in food, dairy, and brewing industries, refrigerants in cooling systems. The overall heat transfer coefficient depends on the following factors. First one, the flow rate, then next the properties of the fluid, the thickness of material and type of material, the surface condition of tube, The geometrical configuration of heat exchanger. Now let's consider the materials used for heat exchanger. The properties to be considered for selection of material for heat exchanger are physical properties, mechanical properties, climatic properties, chemical environment, quality of surface finish, service life, freedom from noise, reliability. The common materials used for heat exchangers are aluminum, stainless steel, and main applications of heat exchangers. A wide variety of heat exchangers is used in engineering applications. Some of them are condenser and boiler in steam power plant, condenser and evaporator in refrigeration unit, oil coolers of heat engine, radiator of automobile, milk chiller of pasteurizing plant, intercoolers, pre-coolers, regenerators. Let's see, this is the boiler type heat exchanger. Okay, this is the condenser heat exchanger AC. In fridge backside you can see this type of heat exchanger, and this is the engine oil coolers, and this is the radiator. It is one of the heat exchanger, and intercoolers which is used in the cars, automobiles, and this is the milk chiller of pasteurizing plant. This is the type of heat exchanger used in the milk chiller plant.